All right, we are back at virtual IoT and Edge Days 2022, and here we have a premiere, or a first in the history of the event. We are having a panel on a concept called Decentralized Spatial Communication. It's my pleasure to welcome Victory and the four panelists. So I will let you, Victory, run with it. Please introduce yourself and your panelists, and looking forward to see what you have to say on this intriguing concept.
Wow, thank you very much. Can you hear me clearly? Just give me a heads up if you can hear me clearly. Yes, oh, great. Awesome. Hi, everyone. My name is Victory, as you can see on the screen, and we'll be taking you through a unique concept called decentralized spatial communication. Now, in this session, we're going to have three parts, right? In the first part, we're going to show you a presentation, basically to give you a bit of an overview of what we're talking about. And then in the second part of this session, we're going to have the panel discussion, and that's where you get to meet the rest of the team, Professor Herman, Shun-Yun, and Charl. Apologies that Alida couldn't make it. And then in the final session, we'll be talking about, we'll be taking in questions and answers. So during this conversation, whether it's via the presentation or the panelist discussion, feel free to type in your questions in the chat box, and we'll do our best to address as many questions as possible. Now, before I start, I would just like to say a big thank you to the organizers of the event, from Sarah to Serena to Hassan. They've been helping us greatly. They've assisted us so much, and we'd like to say thank you for the opportunity to present this unique concept, something we like to call the next big thing. Now, before I start, I would like to quote Reid Hoffman, the co-founder of LinkedIn, who said this, right? If you're not embarrassed by the first version of your product, you have launched too late. As we proceed with this presentation, you may or may not see gaps in the concept, but this research is almost 20 years old now. So the architecture is solid, the approach is solid, and the code base is solid. So we want you to take this journey with us as we introduce you to this unique concept called decentralized spatial communication. Now, for today's session, we'll start with a bit of a background, what the state of IoTs are, the current state of the nation. Some of you might already know this. Then we'll proceed to talk about something called the publish subscribe architecture, to be more specific, the MQTT architecture. I think some of you have seen it in the previous talks. It's a unique library used as a scalability solution. So we're going to talk about how it is, what it is, and how it works. Then we proceed to talk about, spatial publish subscribe architecture, right? That's the unique proposition that we're offering. How does it work exactly? How is it different from what currently exists? We'll also show you exactly, some of the preliminary results we've obtained from just basic tests we've run in the laboratory. Now, as to the next step, we'll also go through the next steps as to, what our key asks are, what we want from the audience today. What we also go a bit of as to the overview and a summary of what we've talked about in the presentation. Now, let's go straight into it. So some of you have probably heard this. We've heard this over and over and over again, that, in the next few years, there's going to be an explosion in the number of IoT devices globally. I mean, this is a forecast from IoT Analytics predicting that in the next 3 years, there will be over 27 billion IoT nodes in the market. I mean, that's a lot. That's literally 3 years from now. And with this rise in demand, it basically means there will be a need for robust infrastructure, for scalable or highly scalable infrastructure, or something to manage that kind of scale. And we believe we've come up with a solution that could potentially solve that. Now, the theme of this event, I think, is centered around edge computing, and that it's a computing that believes that this computing should happen closer to the data source, and we have successfully managed to do that with our unique solution. And we're going to talk a little bit about that later as to exactly how that works. But before I begin, let me continue. Before I go into the details of the solution, let me explain exactly, what MQTT pops up is for the audience, the people in the audience that might not understand what it is. It's basically a unique architecture that consists of publishers and subscribers, where messages are being sent and managed through something called a broker. Now, I'm going to give an example so everyone might be familiar with. As some of you may know, Twitter, the platform. Twitter, you'd have a publisher. Let's use an example of Jordan Peterson is a publisher on Twitter, and you have subscribers who subscribe to messages from Jordan Peterson. So Twitter has an infrastructure or a brokering mechanism that manages the messages between the publisher, Jordan Peterson, and his subscribers. And this way, you're able to provide a highly scalable infrastructure. That way, not everyone in the Twitter network gets, the messages that are published. And basically, this is how it works, right? Messages are sent between publishers and subscribers, specifically in the MQTT space. Now, what is our unique proposition? We've introduced a new concept called spatial publish subscribe, right? And what this simply does, it's very similar to channel based, by the way, to the existing channel system or topic system, except in our system, we are using the spatial information to perform brokering. So in our case, we're saying rather than publish to a topic or a channel, we are going to be publishing to spatial areas. Now, we're able to achieve this because there's been a significant growth in devices that have some form of spatial information, like a geolocation or your map data or your phones, for example. So this is practically possible because more and more devices are built in with some form of spatial information, and that way we're able to leverage communication between clients. Now, I'm going to use the image on the second screen. I don't know, just look at the image on the left. You can think of that area as a 2D area, right? And in this 2D area, you have zone A and in zone B. And in zone A, you can think of subscriber A with a region, and subscriber A would receive messages from publisher 1 and publisher 3 because there's an overlap there. However, subscriber A will not receive messages from publisher 4 because there's no overlap. Now, each of these zones is managed by a broker. So a key difference between our system and the existing system is now we're doing something with multiple brokers, right? With multiple systems that manage the information. Now, how exactly do we do this brokering mechanism? There's a unique library called VAST. This vast library was designed initially for virtual worlds, right? So stuff like Minecraft and MMOs, it was designed so that these worlds could be built more scalably. So what we have managed to do, we've managed to extend this library to support MQT applications. Now, as to how it works, there's brokers, as you can see, there's a 2D space, there's a partitioning, and I will try to not go into too much detail today, but if you would like more information, we're going to share links later in this presentation as to how to get involved with this. But basically, you have brokers and you have clients, and the clients the clients are managed by a broker within a specific region. These regions are partitioned by something called the Voronoi overlay network. That way, we're able to perform some form of balancing mechanism to make sure brokers are not overloaded with messages, for example. And it's built on a distributed network. So this way, this library allows the system to self-organize itself, to self-correct itself, and highly scale when clients are added to the system. Again, there will be links shared if you want to read more about the technical detail, exactly what these things are, but there's lots of documentation as to how the system exactly works. Now, I'd like to share some results exactly as to, some of the things we observed. Now, so what we did, just to give you a bit of background, we took an existing JavaScript library, an existing, MQTT library, a JavaScript one. And what we did, we performed specific tests on it with one broker, right? We tried to use multiple, but it didn't really work. So we used one broker. And what we did was we sent messages between the clients. And the idea was we noticed something, that as the number of clients increased, especially when it got to the 100 mark, the success rate of the messages dropped drastically, which is expected. Now, I must emphasize that this was done with Raspberry Pi. So this might not necessarily represent an industrial scale, but the patterns show, and it's something that might happen in the scale of cloud, for example, when millions or billions of clients are added to a network with just a few just one broker, for example. The number of the success delivery rate drops significantly. However, on the right, we apply the similar messaging pattern, but with our systems, we use multiple brokers, and you would see that when it's at 100 clients or 120 clients, the messages are successfully delivered when there's over four or six brokers, for example, which is to show that our system scales really well and our system works, right? Something we also measured was a latency. So if you look on the left side of the screen, you see the MQTT, a standard MQTT, the same library. We noticed that as the messages were delivered, as the clients increased, the latency increased as well. You can see a spike when it got to 80 users, or I'm sorry, 80 clients rather. But with our system, when we adopted the vast MQTT approach, you would notice that the latency more or less stays the same as the brokers increase and as the clients increase. In fact, we notice in some cases that latency actually goes down as the brokers increase, again showing that our system is highly robust and can manage multiple clients when it's done right. Now, why are we sharing this? What exactly do we want from you guys? Why would we share this with the audience? Now, what we want really is ambitious industry partners, right? We're looking for partners who are looking for new technology. We're looking for partners who are looking to scale up their existing technology, for example. We're also looking for people who are looking for collaboration opportunities. So far in this conference, I've heard quite a lot of interesting stuff around MQTT, and I think there's lots of things we can do together. I saw in the presentation template that this is some of the sponsors of this event as well. And if there's any of you listening in the audience, this is a call to you as well to get involved in something really exciting. And I'm going to share links as to how you can get in touch with us. Now, here are some of the links. We have a GitHub library already working, and maybe Charl will talk a little bit about that later as to how you can get involved. We also have some relevant documentation. There's been papers written. There's been research, extensive research in virtual environments, for example, with regards to Minecraft and so on and so forth. You can get in touch with us via email as well at support@vastverse.net or vastverseapp@gmail.com. Now, just to summarize what I just went through briefly. So, like I said, we have a big spike in the demand for IoT devices, and MQTT has been used extensively in the IoT space to solve for scalability. Now, we have successfully extended the library called VAST to support MQTT with something called Spatial PubSub, the unique concept called Spatial PubSub, and with early results, we've noticed that the system works, and now we're simply seeking collaborators to help us extend this library to real-life practical applications. Now, thank you for your time and thank you for listening again. Please feel free to type in your questions in the chat box. We will try to respond to as many as possible after our conversation. But I would like for us to introduce the team now. We're going to just go into a bit of discussion as to exactly what it is, and we're going to basically talk about VAST. Hi team.
Hello.
Can
Hi,
you hear
everyone.
me clearly?
Hi. Thanks, Victory.
Yes. So hi guys, thanks again for joining this. I must say thank you to Professor Herman, thank you to Shun-Yun as well, for giving some of us, me and Charl, for example, an opportunity to be part of this big project. It's quite exciting stuff. It's something that I've seen used extensively across multiple applications by different students. So one key question I do have for Professor Herman, for example, like with the people in the audience, right? I mean, what type of people will find value using this tool, right? What type of technical expertise, what type of industries do you think will be interested in this tool, or in VAST, or the spatial MQTT infrastructure?
Thanks, Victory. So to me, the VAST library, there's two things which it adds. The one thing is this ability to send and receive messages which are filtered according to spatial information and not necessarily channel or topic-based information. So if you've got spatial data and you're like, oh, I just want to send messages to this specific area, then setting something like that up for channel-based MQTT, that might be more difficult. But if you have something which is spatial-based to begin with, then which is what VAST offers, then this is then I think could be of interest to you. And then the other thing is, because we can now organize our messages spatially, and we can basically decentralize the communication. That also allows us to scale up the number of brokers and make certain that messages can be sent from one point of the network to the other point of the network. So in my mind, if you're working with spatial data, if you work like smart factories, or where we have stock items at specific places, or if you're interested in the spatial web, anything to do with spatial data, and you want to be able to communicate, then that's a type of industry or person that I think would find benefit from this library.
All right. Thank you so much for that, Professor Herman. And I think I didn't do something. I didn't introduce the team. As you know, that's Professor Herman from Stellenbosch University. He's the head of department here. He's also the director of a lab called MIH Media Lab. And as you can tell, he's quite excited and interested about edge technology. We also have, he, by the way, is my supervisor for my PhD. And I'm glad again that you're here. Thank you for joining. Shun-Yun on the bottom left of my screen. I don't know what you're seeing on your screen, but Shun-Yun is basically the pioneer for, the unique library called VAST. This is something he started, if I'm not mistaken, in 2004. And I think he likes to call himself a social entrepreneur, if I'm not mistaken, trying to give freedom to everyone, which I must say I've enjoyed a bit of freedom just using this library. And then we have Charl, who, is a master's student, our lead technical developer for this project. We like to think of him as our chief technology officer, our CTO, because he leads the direction as to what, where the project is going. And then you have Victory. I'm here. Hello. I'm a PhD student with, like I said earlier, with Professor Herman. So thank you so much, Professor Herman, for that answer. I think how I actually got involved with this project was from the initial idea was to develop a smart factory application and to, deploy something using VAST. And it was quite a journey. This was about 3 years ago. There's been quite a bit of pivot since then, but it's exciting stuff. So I have a question for Shun-Yun, though. What's the benefit of this library to the current audience, right? Both in the medium and the long term? Because at the moment, I know the library is quite extensive. It can be used in IoTs, for example. It can be used in Uber-like applications. It can be used in virtual world applications. So with the current audience, which I'm guessing with specifically IoT audience, what do you think the key benefit is of this library to this audience? What do they stand to gain in the medium and long term?
Okay, all right. Thanks, Victory. So I think we all know that one of the key things why channel-based pops up is kind of important is because it's easier to develop, right? You make messaging into just you publish and you subscribe, right? And it's an easy concept. And I think similar things also happens for spatial pops up, spatial data, where instead of you try to figure out how to do various kind of communications, you just subscribe to areas, you publish the areas. Okay, so the first thing I think is it makes development easier for developers or for industry if you want to get your prototype out quickly. And this obviously this kind of construct is I will call it a primitive, right? It's a kind of a simple construct. So pops up, channel based, and now we have spatial based. And I think the medium to long term implication of this is as your application becomes bigger, right? So you can quickly get your prototype out. But if you started to have more devices or more clients, users, you don't have to change any of your code, right? The beauty of this is once it's done, it's there. And all the scalability issues is taken care, by this mechanism. So I think in the beginning, it's ease of development, but in the later stage of the project or your application, it's really about the scalability and ease of maintenance. So just like pops up, except we're talking about spatial data or geospatial data. And I do see, besides IoT, as a great arena to get this kind of things developed or deployed, but also in the future, we all know metaverse is coming, right? And metaverse is entirely spatial, blending both virtual and potentially physical items as well. So I think if this is, kind of more mature, it can be a great primitive foundation to develop metaverse kind of applications, or, like digital twins, where you have physical and virtual blend together. All right.
Okay, thank you for that, because I think I can relate to that. One of the things I say, and I probably say it a lot to you guys, I'm quite impressed by how the project has been able to stand the test of time. Right, it's a project that started in what, 2004, maybe even before that, but that's where the first publication came in. And even after all these years, the research is still relevant even till today. And that's what I think a key value to potential collaborators in the audience. What they can see is, that the next 10 years, if you're using this library, it's something you can still use, because there's always updates, there's always new changes. You don't have to practically replace your whole system, which is also something I find interesting, where with our MQTT software, or our MQTT code base, you don't have to replace your existing MQTT infrastructure. It actually supports it. It's basically an extension of what's currently existent, and for that, I can truly relate to that. Now, this is a question for both Shun-Yun and Professor Herman, because I think you guys are the foundation, more or less the founding fathers, quote unquote, of this very unique library. What is the bigger picture, right? What does VAST aim to accomplish what does a perfect VAST world look like? We can start with Professor Herman.
So, so I got involved with this via my interest in virtual worlds. I was playing around with Minecraft and making that scalable and decentralized. And then I think I met Shun-Yun in 2011 or something at the conference about virtual worlds. And that's where I also learned the first time about spatial PubSub. And then we started collaborating a couple of years later. And part of the work that we're doing is trying to take something like the spatial PubSub communication and put it into like virtual worlds and MMOGs, specifically Minecraft, because it's popular and you can mod it. So that was a easy vehicle to do. So to me, what we want to accomplish is, just as MQTT, for instance, is one of the very popular protocols that's used for communication in the IoT and Edge world, we want VAST, or this concept of spatial PubSub, to be one of the popular and commonly used communication protocols for the spatial web. That's our end goal. That's where we want to end up. When people, just as people are talking about MQTT now, we want in a couple of years people to speak about, VAST, yes, everyone knows what VAST is. And in essence, then what we want to do is we want to help build this backbone for the scalable, decentralized spatial web.
Okay. Thanks,
Okay.
Professor Herman.
Yeah.
So basically, to rule the world.
Yeah. Well, I think
but you got the idea.
I like to add another dimension to this. We all know that mobile devices are on the rise, right? Both mobile and also IoT devices, and a lot of them are going to be spatially relevant. Placed in different parts of the world, in the oceans and whatnot. And also, a lot of that is going to be spatial data. So the question becomes, how do you manage all those things in an easy and also scalable approach, right? And obviously, what we are looking at is, well, it's just a what if question. So let me just project it 10 years, right? Or even 20 years, like what I'd like to see. Okay. What we would like to see, I believe, is, if looking back from 10 years or 20 years, is that there's already a sort of a public infrastructure, okay, that's available for anybody to develop spatial applications, right? We know how popular and useful Google Maps, Uber are, right? And they are nice. It's like you can also develop things on Google Map or OpenStreetMap. It's an infrastructure. However, like for a lot of the other, let's say you want to develop a new Uber for, let's say, elder people, right? or fresh food delivery, a different kind of Uber. You don't necessarily have access to the Uber infrastructure, right? Or all the nice, neat things that Uber, the company, has. And what we're looking at sort of as a vision is that kind of capability in terms of collecting, processing, managing, retrieving spatial data can become really accessible to almost anyone, any developer, even any individuals. Okay, so I guess what I'm sort of imagining and seeing is a kind of a public spatial infrastructure that all kinds of spatial apps can be developed on top of that and potentially hosted by, volunteers like the Bitcoin network. And the neat thing about the design of VAST is that it was designed from the ground up to be fully decentralized. Because what, kind of how it started was in the virtual world space, and we were envisioning the future virtual world, which is happening now, the metaverse. We are talking about not just hundreds, but millions, even billions of participants, right? Entities that's interacting in a spatial way. So I guess that's the long-term thing we'd like to accomplish, a public spatial infrastructure for everyone to use. And part of the internet as well. Yeah.
Very nice. Thanks for that, Shun-Yun. I think in my project proposal, one of the key things I added was, the fact that this project could potentially be a game changer for startups, right? Where as a startup, if you wanted to compete in the metaverse, you don't have to have $1 billion like Microsoft and Amazon to compete. And VAST potentially provides that platform. So again, to the audience that's listening to this, we would like for potential collaborators as to getting this started and deployed in real life applications, potentially starting with IoT environments. Now, this question is more of a personal one because I think Professor Herman did share his personal motivation as to what led to the development of VAST, right? He was involved with virtual worlds and he was looking at scalability solutions. But what led to the development of VAST from your perspective, Shun-Yun? Because you started it and this was what, 2004? I don't even think the metaverse
2003. That was my master thesis, actually. When I started my master at graduate school.
I don't think the metaverse conversation had started yet. Maybe gaming, but even then, I think that was the early stages of Internet 2.0. Now there's conversations around Web 3.0, metaverses, and it feels like, or it seems like, VAST could potentially play a big role in this. So what exactly led to this? What was the motivation behind the development in that period?
Okay. It was actually a simple question. I think, and for the audience, I think can ask yourself the similar question as well. When I was starting my master work, I asked myself, we all know how computers have evolved in the last 30 years, right? From Zoom to, really small devices. And what's going to happen for the next 30 years? That was the question I asked myself when Moore's law still continues. So what I came out was AI and VR, okay, virtual reality. So we're talking about wearing glasses and we can have photorealistic interactions, right? But that's not going to happen just for the four of us or maybe tens of hundreds of people. Potentially, we're talking about in the tens of thousands, millions, even the billions of people range. The question then becomes, how can you build an infrastructure that actually supports that many people or interacting entities, right? So I started, and that was when peer-to-peer was really kind of popular for file sharing. Skype was there, different kind of applications. So we were a bunch of early researchers thinking, well, this peer-to-peer thing is affordable, it's cheap, and it's scalable. Can it be applied for virtual world setting? So that started the whole thing. And I believe, we have one of the designs that's kind of more elegant, that it can be fully decentralized and highly scalable. And I'm glad to see that, now it's still relevant and, perhaps even more so for the
Yeah.
upcoming mobile device IoT revolution. That's already in the process.
All
So,
right.
so just for interest sake,
Wow.
Victory, the term metaverse actually comes from the 90s. I think it was first used in a book called Snow Crash, written by Neil Stevenson. So it's been around a while. I think even before Shun-Yun started with his masters.
Right.
Oh, okay.
And I think something which Shun-Yun has touched on is this: in AR and VR, people have been very much focused on the device, the goggles or the what you use to look around with. But there hasn't really been very much work done with, okay, but now you want to interact with people. So when you change something environment, everyone else needs to be notified of that change in the environment. And how do you do that in a scalable manner? And that's part of what we're trying to solve with this spatial PubSub paradigm that's implemented in this vast library.
Okay. Thank you, sir, for that. That's one thing I can fully agree with. It's very scalable. I've seen the results over and over across multiple applications, and I can't actually wait to sort of see it working in real life applications. So just a question for Charles. So I think this is more as our chief technology officer. If there are technical people in the audience, because I do believe there are people that they might not necessarily have the resources or the access, but they might be willing to contribute to the project. What do you think they can do to get started? What do they need? Do they need to be highly technical? Do they need to have some form of background in VR and so on and so forth?
Thanks, Victory. So currently, I would suggest that interested parties currently we're only really looking for people who are interested enough to work with, a prototype. It isn't production ready, but we do have a testing environment and a lot of documentation on how to write your own unit tests and how to simulate different nodes publishing messages. And anyone who's interested in providing feedback or potentially being a development collaborator, we have a fully working testing environment under the same library in GitHub. And I do want to point out that in our upcoming release, VAST would be ready to work with existing MQTT applications. However, with a footnote, it's going to be a prototype. Please don't push to production.
So I could just add that we made a conscious decision a while back in the project that making it compatible with MQTT, slight change in the messaging protocol means that if you have if you have clients or an application which is compatible with MQTT, it means that you can basically with minimal effort adapt that and then basically have a spatial publish subscribe functionality. And actually, I think our modified MQTT server simultaneously supports both the channel-based paradigms. You can do your normal channel-based stuff, but you can also then, just by sending a special type of topic, which the details should be in the documentation, you can basically send spatial messages as well. So we see it as an extension to the MQTT protocol, with now the addition that you can have multiple brokers and they can also send messages to each other. There's also a nice tutorial video which shows you how to get started if you want to find out your own computer.
I was just gonna hammer on that one of the things we've tried to accomplish in the past few months is to make the work as simple as possible, because I know once you check out the documentation, for example, you might get overwhelmed by 20 or 100-page thesis document. So we've tried to simplify you don't necessarily have to be in the virtual environment or the virtual field to know how to use the spatial PubSub library. So we do have the documentation. And again, please feel free to get in touch. Feel free to reach out to us. I'm just going to ask that the moderator share my screen again, so that if you missed that, you can see that, or if people are just joining, they can see the contact details. But yeah, thanks so much, Professor Herman. Thanks so much, Shun-Yun and Charl. I would hand over back to Frederick, and he can perhaps show us questions from the audience.
Yes, thank you very much. So no questions for the audience, but plenty of questions from me. So I guess, I was part of the audience, so I guess that counts. And in the audience, if you have any questions, please type them and I will relay them and, insert them into the conversation. So the one thing I wasn't aware, I read up a bit about your initiative beforehand, but I wasn't aware that it had been running for so long. You mentioned the initial paper has been published, over 15 years ago at this point, close to 20. So what made you at the time pick, let's say, MQTT as a base for that compared to, let's say, DDS or alternatives there?
I had a colleague who had some experience with MQTT, and he used it in his IoT applications. And a colleague at the University of Stellenbosch itself, and I also had a colleague at the University of Duisburg-Essen in Germany who's also had some experience with MQTT. We'd used it in 2015 on some art and science collaboration project. So we knew MQTT, we knew it had been used before, and we're like, well, it's the standard is available. There's a lot of open source libraries out there, so it's it's something that we can get and easily modify and adapt.
Yeah, that makes sense, and certainly I think it was a great pick given what you were trying to achieve. I'm a bit partial there. Obviously, we are big on MQTT at Eclipse and in Eclipse IoT in particular. But yeah, curious about the process. Now we discussed a bit things that you have in mind, let's say for your roadmap and all of that. But if we look, let's say, past the next 6 months or the next year, what would you see, let's say, on the 5 or 10 year roadmap for this, supposing it continues? Have you big ideas you haven't explored yet? Maybe a component of AI to affect the routing or the dynamic adjusting and all of that?
So I mean, we have a proof of concept integration with the Minecraft MMOG, which has been tested on kind of a small scale. So one thing we want to do is we basically want to scale that up as well. And I mean, our ambitious goal is to have about 100,000 simultaneous users in a single virtual environment. That's one thing we want to get in about 5 to 10 years. One other thing is that I think Victory mentioned that scaling is very important for us. So what we don't have at the moment is auto scaling. So if you add nodes to the system, yes, then you're going to get more functionality, but that's not something which happens automatically at this stage. So the whole auto scaling up and down, all the things you get on EC2 and all the cloud platforms at the moment, that's not something which is currently built in to the system at the moment. We have deployed a kind of a proof of concept, a chat app on Amazon EC2, just to show that, yes, it's basically a single broker, and then we basically, it uses the spatial publish subscribe communication protocol underneath, and it was basically just a way of making certain that the library works. We can deploy it on your typical cloud infrastructure, and and we can basically have a proof of concept that we can show to people. Something which Shun-Yun I think also has mentioned quite a lot is we definitely want it to be something which is open source, something which is not owned by a specific institute or company or whatever. We want it must be like TCP/IP. It's just there, you use it. The same type of idea.
Yeah, that makes sense. And so one thing that we've been doing in our specifically Edge native working group recently, we started a publication on medium.com to share thought leadership. And the first theme that we tackled is device attestation, the fact that you want to prove that with the TPM and certificates and all of that, that this device is trustworthy, that you can deploy it in your infrastructure. One big thing into that conversation that comes on the top, so to speak, is the fact that maybe you want at some point, at least for some use cases, location attestation, the fact that this device is actually in the place it should be. So is one of the goals of your project to somehow provide a solution for that? Or could it be? I'm maybe fantasizing there.
No, that's a good question, actually. I don't know, Shun-Yun, if you want to.
Okay. I have to be frank, I'm not that familiar with the space you're talking about, but I'd like to add to Herman that seeking the protocol aspect to be standardized, I think that's one of the things that we like to see. So once if it becomes kind of a standardized thing, then there can be different implementations. Yes. I think the vast design is really a design. Right now we have a JavaScript implementation, which is neat because it can also be used both in server side, but also client side, like browser environments. Mm-hmm. And I think that's a really interesting, technically speaking, in terms of you can have a cloud to peer-to-peer to a hybrid kind of deployment model and anything in between. So I guess that's one aspect to perhaps to blend it into some of the other things. Right. I don't know if that answers the question, but go ahead.
I would also say that I think we've already succeeded in our reason for coming here, because you've already given us a very good idea of, what is something that's needed by. It's like, can I trust where you say you are? And that's an important thing. And we were talking to a company called Versus.io over the past couple of years. And they were talking about basically smart spatial contracts. No idea how they're planning on doing it or what the infrastructure is behind it. But this idea that you can have a badge that you wear and that allows you access to, like, if you're a doctor, it allows you access to certain parts of a hospital or not, things like that. And having like trusted location information, I think is a key component of that. And I think that's definitely something that we will add to our list of things that people from industry would find useful in a library like this.
Oh, you can be sure about it. And in a previous life, I was working for a company making collaboration products, and we had lots of hurdles to adoption in healthcare or defense, environments where, you don't want those messages or those files to be, yes, they can be shared, but they shouldn't be stored on a cloud server in the US or in a remote location. They should stay in the country, in the province, in the state, whatever jurisdiction you can imagine. And so, essentially, I think we are onto something here.
Well, thanks for sharing. Because one of the things we can support is not to store things centrally, but in of a decentralized way. Yes. So that one make it more privacy sensitive in a sense. Yeah.
What we have done is we have tested that the system actually works with TLS, the secure transport layer type of thing. So at least the messages are encrypted as much as you can trust HTTPS and things like that. Yes. So at least we've got that part covered.
Yeah, of course. Yeah. So I think we would need to schedule a little follow-up call on something offline privately, because we have a number of things at the foundation probably to offer to the project. For example, people don't know that, but we do open specifications at Eclipse, which means that essentially we have a spec process where we set up things to encourage open collaboration around those things. Obviously, we provide services to open source projects. And eventually, even we are taking the Sparkplug specification, which I referred to in my talk this morning. Maybe you caught it or not. But in any case, Sparplug is now an open spec at Eclipse, and we will bring that as an international standard at ISO IEC, for example. So if you have ideas like that, then certainly I would be happy to work with you all on initiatives like that.
Great.
Wow. Excellent.
Sounds exciting.
Thanks.
Sounds exciting. I will. I know that these videos are going to be uploaded on the YouTube page, right? So I think I would love to find out more. Actually, maybe some links or help.
Yeah, absolutely. In any case, I think I will invite you all, if you can make it, to some sort of call, and then we can hash out that offline, not to bore everyone in the audience with our little chat there. As a last maybe question before we ramp down this session and slowly get to the last one in the day. Maybe you caught the Zeno presentation just before this one. Were you able to watch it?
Just
we were
a
getting
little
ready for
bit,
this one.
but it was,
Okay, well, that's fine,
difficult
and please catch it on YouTube after the fact. It's just
cool.
that I see some similarities between what they are trying to achieve in Zeno and what you are working on, and I'm not saying that the two are exactly similar or anything, but there are a few similarities that are interesting. Zeno is a PubSub protocol as well, but they built it from the ground up to support multiple transports, layer 2, layer 3, quick UDP, TCP, whatever. But the thing in Zeno is that it's PubSub, but it can run, in a mesh or clique, or if you deploy a kind of routing node, then the routing node becomes this gateway to remote locations, so to speak, and it will affect the routing. And then they integrate into protocol distributed storage. They will have queries, evals built into the protocol. So there are maybe things that you could take inspiration of, or they could probably borrow a few ideas for you as well. Anyway, so another area potentially for collaboration. I will make sure to provide you a few links as well. And in the audience, if you're curious about it and you missed Angelo's presentation right before this one, then please watch it on YouTube.
Yeah, thank you. I think it's the one with the MQTT over Quick, right? I think that's
MQTT over Quick is the one after this. So
is the one after this?
Yeah, absolutely. Okay. But once again, that's an interesting idea because. I wasn't aware. You could do MQTT over Quick, so I'm certainly looking forward to that last session of the day and learn about it. All right.
Thank you so much, Frederick.
So Victory and everyone else, thank you so much for this great panel. It was fantastic to have you on board, and certainly I look forward to meet you again in a different context. And congratulations on what you did. I think it's really an interesting project, and looking forward to see how I can support you.
Cool. Thank you very much.
So
and thank you for this.
Thank you so much.
Thanks for the opportunity as well.